Hi everyone, in this video on geometric sequences, we're going to be learning about a formula which I like to think of as the real formula for the general term of a geometric sequence. And as we're about to see, this formula allows us to calculate any term in the geometric sequence, provided we have two things. Those being the common ratio and any other term in the geometric sequence. So we'll start by writing the formula down, and I'll then show you how it can be used to calculate any term we need in a geometric sequence, provided we have another term and the common ratio. After that, I'll spend a bit of time to explain how or why the formula works. And finally, we'll finish this video with an exam question in which we'll need to find a geometric sequence's unknown common ratio and its first term. So, as you can probably guess, this will be quite a long video, so I've added timestamps or chapters at the bottom of this video for you to skip from one section to the next if needs be. All that being said, let's get started, and I'll go ahead and write the real formula for the general term of a geometric sequence. Here's the formula. The general term or nth term of a geometric sequence, so typically we say u sub n, is equal to any other term in that geometric sequence, so I'll say u sub p, times the common ratio r raised to the power of n minus p. And I'll go ahead and box that formula. Do make a note of this. And now let me quickly say that if you're studying geometric sequences, then you've no doubt already seen the following formula, u sub n, the general term, which equals to the first term, u sub 1, times the common ratio r raised to the power of n minus 1. And in fact, I'll go ahead and box that one as well. There we go. This is the formula that you probably have already seen. Notice that the only difference between these two formula is the fact that in the one we're going to talk about in this video here, instead of having the first term in this formula, we have any other term in the geometric sequence. So to get from the formula written in gray here to the formula written in green, all we actually have to do is replace every one that we see by this letter P. That being said, let me quickly show you how this formula can typically be used. And so I'll quickly write EX here for example. And let's say we're given a geometric sequence whose third term is 3.6 and whose common ratio r is equal to 3. And so let me quickly write that. We're dealing with a geometric sequence with third term 3.6. So I'll say with u sub 3 equals to 3.6 and common ratio r which equals to 3. And let's say we're asked to do two things. So I'll say, first of all, let's say we're asked to find the seventh term of the sequence, u sub 7. And secondly, so question 2, let's say we're then asked to find the first term of the sequence, so that's u sub 1. Okay, well let me quickly write SOL here for solution. And now let's see how we can actually use this formula. The key thing to realize about this formula is that the term we see on the right-hand side, this u sub p, can be absolutely any term in the sequence. So, in other words, provided we have any term in the sequence and the sequence's common ratio, we can find any term we want. And so for this first question, we need to find the seventh term. And so if I quickly start by copying the formula, we have the nth term or general term, which is equal to u sub p times the common ratio r raised to the power of n minus p. And so to find the seventh term, we replace every n we see inside this formula by 7. And since we're given the third term of the sequence, we'll replace every p we see here by 3. So this formula becomes the seventh term, u sub 7, is equal to u sub 3, the third term, times the common ratio r raised to the power of 7 minus 3. Of course, since 7 minus 3 is equal to 4, this quickly turns into u sub 7, the seventh term, is equal to the third term times r raised to the power of 4. Okay. All we have to do now is replace u sub 3 by 3.6, as well as r by 3. So this becomes the seventh term is equal to 3.6 times 3 raised to the power of 4. And at this stage, we can move over to the calculator, and you can see mine on the screen here. And so I'll calculate 3.6 times 3 raised to the power of 4. And I click on Enter. And we're done. The seventh term in this sequence, so u sub 7, is equal to 291.6. And I'll go ahead and box that result. There we go. We've now answered question 1. Okay, now before I work through question 2 here, let me just stop for one moment to highlight the advantage of the formula we just used. That is, the advantage it represents compared to the regular formula we have boxed in gray here. If we had sought to calculate the seventh term using this formula, the one we're used to, then we would have to start by finding the first term of the sequence, u sub 1. But thanks to this new formula, there was no need to do that at all. Indeed, since this formula involves any term in the sequence as well as the common ratio, we were able to calculate the seventh term, and in fact we'd be able to calculate any term, using any other term in the sequence and the common ratio, which is a clear advantage over the formula that we have boxed in gray. That being said, I carry on, let's work through question 2. Now for question 2, we need to find this sequence's first term, which is a very common question in exams. And so quickly copying that formula again, that's u sub n, which is equal to u sub p times r raised to the power of n minus p. To find the first term of the sequence, we'll replace every n we see in this formula by 1, and since we're given the third term of the sequence, we'll replace every p we see by 3. So this becomes u sub 1, the first term, is equal to u sub 3, the third term, times r raised to the power of 1 minus 3. And since 1 minus 3 is equal to negative 2, this quickly becomes the first term is equal to the third term times r raised to the power of negative 2. Okay, all we have to do now is replace u sub 3 by 3.6 and r by 3, so that this states that the first term is equal to 3.6 times 3 raised to the power of negative 2. And at this stage, I turn over to my calculator again, and I go ahead and calculate 3.6 times 3 raised to the power of negative 2. And I click on Enter. And we're done. This sequence's first term, u sub 1, is equal to 0.4. And I'll go ahead and box that result. Okay, now that we've seen how we can use this formula to calculate any term we want, let's get an idea of how or why this formula actually works. And for that, let me start by writing a few very generic terms in a geometric sequence. In other words, let me start by writing u1, u2, u3, u4, and so on and so forth. Okay, now if these are terms of a geometric sequence, then we already know that to get from one term to the next in this sequence of numbers, we always multiply by the same amount, which is known as the common ratio. And to illustrate how or why this formula works, let's say, just like in this example, we know the sequence's third term, so that would be this term right here, u sub 3, and we need to find the sequence's seventh term, which would be right here, u sub 7. Then to get from the third term to the seventh term in this sequence, we'll have to multiply the third term by r, followed by r again, followed by r again, followed by r again. So that's times r, times r, times r, and times r. In other words, the seventh term is equal to the third term times r raised to the power of 4. And in fact, I'll write that here. The seventh term, u sub 7, is equal to the third term times r raised to the power of 4. But rather than using an illustration like this one, we could have found this power of 4 directly. Indeed, the power to which we have to raise the common ratio here is simply equal to 7 minus 3, which is exactly what this formula is telling us to do. And so to really illustrate that this result here is what this formula is telling us to do, we could rewrite the right-hand side as u sub 3 times r raised to the power of 7 minus 3, which is exactly what we'd get from this formula here. Similarly, when we had to find the first term of the sequence, so that would be this term right here, starting from the third term, we'd have to divide by r and divide by r again, which is the same thing as multiplying by r raised to the power of negative 1 and multiplying by r raised to the power of negative 1 again, which explains the r to the power of negative 2 that we had here. And that's the whole idea. This formula allows us to avoid having to write all these terms out in order to figure out which power we need to place on the r. Instead, we can find it directly. Okay, now as I said at the beginning, to finish this video, let's work through an exam question, which becomes rather easy to solve thanks to this formula. And here's the question. Here we're told a geometric sequence has fourth term u sub 4, which equals to 57.6, and seventh term u sub 7, which equals to 460.8. And we need to do two things. First of all, we need to find the common ratio, and secondly, we need to find the first term. Okay, well let me start by writing a little 1 right here, since we'll start with the first question. And now let's see how we can find the sequence's common ratio. Well, looking at this formula again, we can also think of it as a very convenient formula for finding a common ratio. Indeed, provided we have any two terms of a geometric sequence, so u sub n and u sub p, we'll be able to quickly derive an equation for the unknown common ratio r. Indeed, let me quickly copy this formula again. So that was u sub n, which equals to u sub p times r raised to the power of n minus p. But now on the left-hand side of this formula, let's say we have u sub 7. In other words, let's replace every n that we see here by 7. And for the u sub p that we see here, we'll say that it's the fourth term. In other words, we'll replace every p we have in this formula by 4. So if I go ahead and write that, that would be u sub 7 is equal to u sub 4 times r raised to the power of 7 minus 4. And of course, since 7 minus 4 is equal to 3, this quickly turns into u sub 7 is equal to u sub 4, the fourth term, times r raised to the power of 3. Now, replacing u sub 7 by 460.8 and u sub 4 by 57.6, this becomes 460.8 equals to 57.6 times r raised to the power of 3. And looking at this, we quickly realize that the only unknown we have here is the common ratio r, and that's exactly what we're trying to find. And so to do that, I'll get rid of this 57.6, which is multiplying the r cubed here, which I do by dividing both sides of this equation by 57.6. So I'll divide the right-hand side by 57.6 and the left-hand side as well. And now carrying on with the working right here, on the left-hand side we'll have 460.8 over 57.6, which will equal to r cubed. Okay, back on my calculator again. On the left-hand side we have 460.8 divided by 57.6, which is equal to 8. So this equation is actually 8 equals to r cubed. And by all means check with your calculator if needs be, but if r cubed equals to 8, then r is equal to the cube root of 8. In other words, r is equal to 2. And we're done. We've now found this sequence's common ratio. Okay, now that we have the common ratio to find the sequence's first term, in other words, to answer question 2, we can use this formula in exactly the same way as we had done previously. And so let's see, I'll answer question 2 up here. There we go. And now to find this sequence's first term, u sub 1, using this formula, I'll start by copying the formula one last time, so that's u sub n, which equals to u sub p times the common ratio r raised to the power of n minus p. And now replacing every n that I see by 1, since we're after the first term, and every p we see by either 4 or 7. It doesn't matter which of the two we choose, but I think I'll go ahead and choose 4 since the number here is smaller. Then this formula quickly becomes u sub 1 is equal to u sub 4, the fourth term, times r raised to the power of 1 minus 4. Now 1 minus 4 is negative 3, so this becomes the first term is equal to u sub 4 times r raised to the power of negative 3. And now since the fourth term u sub 4 is equal to 57.6 and r is equal to 2, this becomes the first term u sub 1 is equal to 57.6 times 2 raised to the power of negative 3. And so once more I turn over to my calculator and I calculate 57.6 times 2 raised to the power of negative 3. And I click on enter. And we're done. We can see on the calculator that the first term, u sub 1, is equal to 7.2. And that's the final answer. And there we go. That's how to use this real formula for the general term of a geometric sequence. There we go, everyone. I really hope that helped. And if it did, please hit like on this video, drop a comment down below, and even subscribe to this channel to help get this video to as many students as possible. All that being said and done, that's it for this tutorial.